This video is going to discuss section 3.3, conversion problems. The objectives we're going to cover: construct conversion factors from equivalent measurements, apply the techniques of dimensional analysis to a variety of conversion problems, and solve problems by breaking the solution into steps. Convert complex units using dimensional analysis. So what are some conversions that you have used? I'm sure you've done conversions. I have two pictures up here. I'm sure you've all converted quarters and dollars. If you had 8 quarters, you knew you had $2. 60 seconds equals 1 minute. Okay, I'm sure you've done conversions that way, converting seconds to minutes or minutes to seconds. Those are just two everyday examples of conversions. Dimensional analysis is a way to analyze and solve problems using the units or dimensions of the measurements. It is a problem-solving method based on treating units and calculations as if they are algebraic factors, just like x and y. 2 times 15 milliliters equals 30 milliliters. Okay? So we have these units. They're very important. A conversion factor is the ratio of two quantities that are equal to one another. So here we have, I call this an equivalent statement. $1 equals 4 quarters. We can set up as a ratio. $1 is to 4 quarters, or 4 quarters is to $1. In scientific units, we could have 1 meter equals 100 centimeters. Okay, that's our equivalent statement. So we could set it up as a ratio. 1 meter is to 100 centimeters, or 100 centimeters is to 1 meter. We can use it either way. Now, depending on what we're looking for, what we're given, and what we're looking for determines which one we use in our conversion. So when doing conversions, you write the conversion factors so that the unit of a given measurement cancels, leaving the correct unit for your answer. For example, 60 seconds equals 1 minute. Our conversion factor, 1 minute is to 60 seconds, or 60 seconds is to 1 minute. So we have a question here. How many minutes are there in 528 seconds? The 528 seconds is our given. And I call that our given because we put that first. We have 528 seconds. We have seconds here. We want the seconds to cancel out. So therefore, we would use this one. 1 minute is to 60 seconds. The seconds cancel out. It gives us minutes. And it answers the question, how many minutes are there in 528 seconds? Now we just do the math. Even though this says multiply, it's a multiplication, when it's below this line, you divide. So you get your calculator and you put in 528 divided by 60 equals 8.8 minutes. Now I know you could probably do it in your head or just grab a calculator and you don't have to do this step, but I wanted to show you how we can use conversions before we start getting with using more difficult units that you're not as familiar with. Minutes and seconds you're familiar with. You could have solved it in, 0.05 seconds using a calculator, not even writing it down. But this is what you're doing. You're setting up a conversion. You're converting seconds to minutes. And notice how seconds cancel out as if they were both X or Y. We have a sample problem here. How many quarters are there in $75? Again, I'm sure you can do this in your head or quickly with a calculator. But here we just want to get used to using conversion factors. Here's our equivalent statement. 4 quarters equals $1. So we can set up our conversion factor. 4 quarters is to $1, or $1 is to 4 quarters. The quantity given, we have $75. That's our given. We put that first. That's what we have. And we want to know how many quarters that's going to have. $75, we want the dollars to cancel out. So with the dollars canceling out, we're going to use this one. Let me just circle it here. We wanted the dollars to cancel out. And so therefore, dollars cancel out. We're left with quarters, and we just do the math. Now notice we're above that line, so we multiply. 75 times 4 is 300. And so this would be our answer, 300 quarters. This slide is a slide of just equivalents. I have this posted in Schoology, and you should probably make a copy of it. And you can refer back to it when we're doing sample problems. Here we have volume, 1 milliliter equals 1 cubic centimeter, or 1,000 milliliters equals 1 liter. And here we have meters. And these are all equivalent statements, meters and grams. And you're going to probably use these for sample problems. So it's good to have this as just a reference table. Again, I have this posted in Schoology. I would suggest you probably should print it off. So it'd be handy when you do calculations. We're going to be working with exponents. In the back of your chemistry book is a math handbook, page ARG57, math handbook, in the back of the chemistry book, and review multiplying and dividing with exponents. You can go back there and review it. I'm going to go over it now. However, you can also review it in the math handbook. So, multiplying exponents. Let's say 10 to the third power times 10 to the fifth power. When you multiply it, 10 to a power, you add the exponents. So you have a 3 plus a 5 is 8. So 10 to the third power times 10 to the fifth power is 10 to the eighth power. Same thing here, except I have a negative number. And again, you have to review how to add negative numbers. You add exponents. We have 10 to the minus 2 times 10 to the 6. We add the exponents. A negative 2 plus a positive 6 would be a positive 4. Again, you might need to review how to add and subtract positive and negative numbers. You should have had this at this point in your career. And another example, 10 to the minus 4 times 10 to the minus 12. Again, add the exponents. A negative 4 plus a negative 12 is equal to negative 16. You should be able to, you should know how to do this. If not, again, you can review in that math handbook. So this is multiplying exponents. Multiplying exponents. Dividing exponents. If we had 10 to the 8th power divided by 10 to the 5th power, when you're dividing, you subtract the exponents. So 8 minus 5 is 3. So 10 to the 8th power divided by 10 to the 5th power is 10 to the 3rd. Another example, 10 to the minus 2 divided by 10 to the 7. Again, subtract exponents. Minus 2 minus a plus 7. Okay? You change this to a minus and add, and it equals a minus 9. So it would be 10 to the minus 9 power. Again, review this. Probably did this a few years ago in math. Need to get be pretty proficient in this. Third example, 10 to the 6th divided by 10 to the minus 4. Again, subtract the top number minus the bottom. 6 minus a negative 4. Subtracting 2, a minus and a minus is a plus, so 6 plus 4 is 10. So it'd be 10 to the 10th power. So when you divide exponents, you subtract. Okay, when you divide 10 to a power, you subtract the exponents. When you multiply 10 to a power, you add the exponents. Okay, so you should review this. So a sample problem, convert 750 milligrams to gram. From our conversion table, we know 1 gram equals 1,000 milligrams. And we can go back, let's see, where's that? 1 gram is 1,000 milligrams. So this is our equivalent statement. We can have, these are two conversion factors. 1 gram is 1,000 milligrams, or 1,000 milligrams is 1 gram. This is what we know. This is what we're looking for, how many grams. So this is what we're given. We put that first, 750 milligrams. We want the milligrams on the bottom here. So we use this. Okay, milligrams cancel out. Okay, so we use this one, this conversion. Milligrams cancel out, that gives us grams, and then we do the math. 750 divided by 1,000. The 1,000 is below this line, okay, below that line, so we divide. Get your calculator, 750 divided by 1,000 gives us 0.75 grams. Okay, this is sample problem. It's on page 85. You can look at this and I'll explain it. Here we do it in 2 steps. We're doing 2 steps. We can't just do it in 1 step. So what is 0.073 centimeters in micrometers? So this is our given 7.3 times 10 to the minus 2 centimeters. I just converted this to centimeters. I moved it over 1, 2. So that's 10 to the minus 2. We know 10 to the 2 or 100 centimeters is 1 meter. I'm just using scientific notation, exponents here. So we can have a conversion factors. 1 meter is to 100 centimeters. Now here 1 meter on top is to 100 centimeters. And then here 1 meter is to 10 to the 6th micrometers. Again, if you look in that equivalent paper table, you'll see this equivalent statement. So conversion factor 10 to the 6 micrometers is 1 meter, or 1 meter is equal to 10 to the 6 micrometers. So the first step, we have centimeters here, we're going to need centimeters. Here we don't see centimeters, so we can't use this yet. We see centimeters, we want centimeters on the bottom, so we use this. 7.3 times 10 to the 2 centimeters, and we use this conversion. And if we would cross this out, that gives us meters, but the question asks for micrometers. So that means we need to go to this next one. We want meters on, see we have meters on the top here. We want meters now on the bottom, so that's why we pick this. So 10 to the 6 micrometers is to 10 meters. Here the meters cancel out, and we have micrometers, and now we do the math. 7.3 times 10 to the minus 2 times 10 to the 6th divided by 10 to the 2nd power. So you multiply the exponents. You're multiplying 10 to the power, so you add the exponents. 6 plus a negative 2 is 4, 10 to the 4th power. Let me just write this, 10 to the 4th power. And you have 10 to the 2nd on the bottom. Now you subtract, 4 minus 2 is 10 to the 2nd. That's how I got that there. And 7.3, you're just multiplying times 1. If you have a scientific calculator, you can use that, and then you don't have to figure this out. But if people do not have scientific calculators or don't know how to use it, you can just figure it out by hand. So this would be the answer, 7.3 times 10 to the second micrometers. So again, 2 steps. I have 1 step in red, 1 step in blue. First step, I'm converting centimeters to meters, centimeters to meters. Second step, I'm converting meters to micrometers. Many common measurements are expressed as a ratio of 2 units. For example, density is grams per cubic centimeter. So we have to do 2 steps. Okay, grams per cubic centimeter would be density. Ratio of 2 units. So here we have the density of manganese is 7.21 grams per cubic centimeter. What is the density of manganese expressed in kilograms per cubic meter? So we want to convert grams to kilograms and cubic centimeters to cubic meters. Okay, so we're given the density of manganese is 7.21 grams per cubic centimeter. We know 1 kilogram is 10 to like 1,000 grams. That's one conversion. And 1 cubic meter is 10 to the 6 cubic centimeters. And here 100 centimeters, 1 meter. And if we cube both, okay, it'd be 100 to the cube, it would be cubic centimeters. That's how I got that. And this is what we're looking for. So we start with our given. We start with this right here. We're converting grams to kilograms. So 1 kilogram is 10 to the 3 grams right here. Here's my conversion. I've color-coded. And if we stop there, if the grams cancel out, we stop there, we'd have kilograms over cubic centimeters. And we want cubic meters. So now we have to convert. We have to get rid of the cubic meters. We have 1 meter is 10 to the 6 cubic meters. Now let's do this. We have grams canceling out. And now we have cubic meters canceling out. Oops, I can't get there. Cubic centimeters. And what's left is kilograms and cubic meters. And that's what the question asked for. Now we just do the math. 7.2 times 1, divide by 1. So the 7.21 stays the same. And we do 10 to the 6 divided by 10 to the third. 6 minus 3 is 10 to the third. So that's how we get to 10 to the third. Here is 10 to the 6. 10 to the 6th power divided by 10 to the third. 6 minus 3 be 10 to the third. 6 minus 3 is 3. That's how I got that. Okay, so here we're changing 2 units. Changing 2 units. So when a measurement is multiplied by a conversion factor, the actual size of the quantity measured remains the same. Just like 4 quarters, if you have 4 quarters, you have $1. You're not, it's the same measurement. A dimensional analysis provides an alternative approach to problem solving, and conversion problems are easily solved using dimensional analysis. And that's what we were doing. We were using those conversion factors. Homework assignment, read section 3.3, pages 80 through 87.